He is professor at the University of Valencia and director of the Astronomical Observatory of the university, and recently also has been converted into the dean of the Universidad Menéndez Pelayo in the city of Valencia. But I have interacted with him for many, many years because both of us are interested of the relationship between astronomy and culture. And in this aspect, we have been interacting for many years in many conferences. And a few years ago, not so much, a couple of years ago, he invited me to present our book on Egyptian astronomy in Valencia. And then I promised that I would do the same for him here at the ISA. So this is the book he published together with Bernard Jones and Virginia Trimble, The Reinvention of Science, Slaying the Dragons of Dogma and Ignorance. It is a fascinating book, really fascinating. It is controversial. It is a pity that Javier Licander is not here today because he is reinstalling all the instruments in the Teide Observatory. But I don't know if Julia will be connected from La Palma, so maybe they will later discuss on the topic, because the book touches many different aspects. And in this conference, I think he will basically touch a few points of it. Perhaps the most interesting, perhaps the most controversial, perhaps the most fascinating. So I would not say anything longer. So just let Vicent speak. So Vicent, you have the words.
Okay.
Welcome to the IC. It's a pleasure to have you here today.
Okay. Thank you. Thank you, Professor Belmonte, for the introduction. And thank you for inviting me to give this colloquium on a particular view of the history of science. This is not the standard view. I am grateful to the organizers and to Professor Belmonte for making this visit possible. I will speak about a book, yes, but the purpose of the book is well captured, metaphorically, I guess, in its subtitle, Slaying the Dragons of Dogma and Ignorance. The subtitle refers to the famous inscription in the Hunt Lennox globe from early 16th century cartography. Hic sunt draconis, here be dragons. In medieval cartography, such dragons, beasts, animals, such creatures marked the unknown edge of the maps of the world known at that time. This symbolized danger and uncertainty, and in a way, the limits of knowledge. The origin of the books has also, obviously, a personal dimension related the way the authors know each other's. Here are the authors, and the book was written during the COVID. I mean, it was a good task to do during the COVID because we had plenty of time to read. We read a lot, and I will share some of the books or the papers that we read because they were probably the seeds of this book. But also the idea of overcoming dogma and ignorance came at that time because of the reality that we were living in that time in the COVID period. Bernard Jones first met Virginia Trimble in the early 1970s at the Institute of Theoretical Astronomy in Cambridge. This is a picture in the bottom taken at the symposium celebrated there in 71 to celebrate the 60th birthday of Willie Fowler, who a decade later got the Nobel Prize. We can see Geoff Barbridge, Martin Ryle, Donald Lyndon Bell, Stephen Hawking in the first row, Fred Hoyle, Margaret Barbridge, Willie Fowler, also seated there, Martin Rees, Roger Penrose, a lot of Nobel Prizes, John Archibald Wheeler, Tony Hewis, and also we can find my later supervisor, Bernard Jones and Virginia Trimble were there. At that time, I was in the primary school. Years later, Professor Jones became my PhD advisor on the top image at the Nordita and the Niels Bohr Institute. And that was a very nice time where I be embedded in this Cambridge school of doctorates. Professor Timbre and I later co-organized a summer school in Valencia in 2000, entitled Historical Development of Modern Cosmology. I always have some interest for the cosmology. And we collaborated again a few years later in Granada in a meeting titled Cosmology Across Cultures, organized by José Alberto Rubiño and Juan Antonio Belmonte, who are in this room, Francisco Prada and Anchona Alberdi. Our contribution, Virginia and myself contribution for that, was Cosmologists in the Dark, and became the prelude of this book. In 2008, as you can see at the bottom as well, Virginia Trimble was awarded an honorary degree, Doctor Honoris Causa, by the University of Valencia. Well, we go now to the topic of the book. Through the history of science, thinkers, natural philosophers have provided always invisible entities to explain the visible world, the visible universe. This is happening now and has happened always. Phlogiston, for instance, was invoked to explain fire in the 17th century. The luminiferous aether to explain the propagation of light. The homunculus that accounts for heredity, and the crystalline spheres in our field to carry the wandering planets around the Earth. Many of these erroneous beliefs help up progress, just as in our metaphor, as dragons drawn at the edge of the map, discouraging exploration. Yet, these ideas shaped the scientific thought for centuries. Some of these dragons eventually were real. For instance, Neptune, discovered in the year 1846, is a classic example of an unseen entity first postulated because the observations predicted and later confirmed. Others, for example, the planet Vulcan, that it was postulated to account for to explain the excess of the perihelion of Mercury, was never found. And it was a dragon that was delayed by, in this case, a new theory, the general theory of relativity of Einstein. As Alexander Pope once wrote, "Be not the first by whom the new are tried, nor yet the last to leave the old aside." This is a good quotation for life. We will be back to this idea later with a quotation by my model quotation by Max Planck. Long before science became a reality, ancient mythologies also sought to explain the structure of the cosmos. For instance, in Egypt, and this is obviously for Professor Belmonte, the god of air, Shu, separated not the sky from Jeb, the earth. Both were siblings, and Shu wanted them to be separated. And this was the reason that was making life possible on Earth. And this scheme is repeated in all Eastern traditions, in Babylonian, in Chinese, and also in the Judeo-Christian tradition. I mean, the Creator himself puts its thing at its place, including heaven and earth, at the first attempt. However, the process, even in the Bible, explains that it's a process of separation. God saw the light was good, and he separated the light from the darkness, the dry land from the water. The ancient Greeks developed a more philosophical, and we could even say a more scientific account for this. They proposed 4 earthly elements: earth, air, fire, and water. But for the heavens, this was the Empedocles periodic table, if you want: earth, air, fire, and water. But for the heavens, Aristotle proposed a fifth element, the quintessence of the ether. Aristotle distinguished between the perfect eternal heavens and the changing imperfect world beneath the moon, the sublunary region. In that distinction, in fact, we already have seen the first attempt to divide the universe into separate physical entities that we can study in different ways. The Aristotelian and Platonic tradition have arrived as the more influential one. This is not doubt. I mean, but there were other schools in the classical or Hellenistic Greece, particularly the atomists and the Stoics. For the atomist, being Democritus of Abdera, the laughing philosopher, and later developed by Epicurus, the universe was vast, perhaps infinite, and composed by invisible and indivisible particles, and they call it atoms moving in the void. These ideas were later beautifully expressed by Lucretius in a book called De Rerum Natura, a work that imagined an infinite world, multiple worlds, and the universe built from unseen matter. In fact, this was just a first kind of dark matter. Atoms, not impossible to see, that exist, that are indivisible, invisible, but they are moving around the space, and out of which everything was built later. Antiquity also left us another astonishing reminder of how advanced scientific thought was at the time, at the Hellenistic time. In particular, in this book, The Forgotten Revolution, that we read avidly during those days, we can find things like the Antikythera mechanisms. The Antikythera mechanism is a bronze analog astronomical calculator with remarkable sophistication. And it was recovered in a shipwreck near the Greek island of Antikythera in 1900, okay? And they put all the things in the National Archaeological Museum of Athens, and later on they realized that its bronze analog had a lot of gears. You have in the bottom a reproduction of how it works, and it was able to calculate astronomical ephemeris as many of the analog clocks that were developed in the 17th century. But this book that I was talking before, the Lucretius De Rerum Natura, was lost. And then we call it the lost poem. There is a chapter in the book called The Lost Poem. And in 1417, a copy was rediscovered by Poggio Bracciolini, an Italian scholar and humanist, and it was probably in a library in Fulda, in the present-day Germany, close to Frankfurt. We can imagine the journey to retrieve all these books, and reminds me the book of The Name of the Rose, and also, obviously, this book, particularly by Stephen Greenblatt, that talks exactly of this discovery by Poggio Bracciolini, and also, as we can learn here, how the world became modern after this book was discovered. The book and the idea of the atomist rediscovered by the Lucretius Rerum Natura had a notable influence on the thinking of Galileo, Descartes, Newton, for instance, in the idea of the inertia. The story is also a story of invisible entities, and probably one of these invisible entities that has endured for a long time is the crystalline spheres. During Middle Ages, most natural philosophers still consider these crystalline spheres solid and rigid, believing that celestial bodies could not pass through them. This was clearly another example of dark matter. Their persistence during many centuries show how deeply entrenched cosmological assumptions can become when no compelling alternative yet exists. Something similar occurred, for example, with the geocentric explanation of the retrograde motion, using epicycles and deference to reproduce the apparent retrograde motion of the planets. This was just mathematical powerful, but physically problematic. And all these epicycles, deference, crystalline spheres continue with Copernicus. He was also not the first to challenge the full Earth-centered cosmos. His ideas drew on much earlier traditions. For instance, we know, and this is explained in the book, and many people know that his unpublished notes refers to Aristarchus, who was the first to claiming that the sun was the center of the cosmos. On Philolaus, that he knows, we're not talking about the sun, but about the fire. And Copernicus also used the mathematical device like the two couples from the Islamic world. In fact, historians explain that Islamic astronomers helped to build the conceptual bridge between Ptolemy and Copernicus and Kepler. 30 years after Copernicus' death, Tycho Brahe, here we can see that the crystalline spheres also continue with Copernicus. Tycho Brahe in Denmark observed a brilliant new star in the constellation of Cassiopeia on November the 11th, 1572, shining as brightly as Venus, and it was possible to see it during the day. This new star was a challenge for the whole length Aristotelian belief that the heavens were perfect and unchanging. The same star was observed in Valencia. In this case, not by an astronomer first, it was local night workers, shepherds and lime burners working in Torrent. And they noticed the new star and they called Jerónimo Muñoz, who was the full professor in Hebrew, mathematics and astronomy in Valencia. A few years later, the great comet of 1517, observed by both Tycho Brahe and Jerónimo Muñoz, provided further evidence against the idea of the unchanging heavens. Careful observations discovered that this comet was beyond the moon, contradicting the Aristotelian view that comets were atmospheric events. Tycho concluded also that the comet was rounding around the sun, influencing his particular cosmological model. And together with the supernova of 1572, this was decisive for a shift in understanding the structure of the cosmos. And also Tycho realized that the comet was traversing the solid rigid spheres. That means that the spheres could not be really there. An invisible entity had shaped cosmology for centuries, ends with this idea that the planets and the comets in particular needs to traverse them. The idea never vanishes immediately, takes gradually, but it's losing credibility, and within a few decades, this dragon has been defeated as well. The same pattern also has happened in chemistry, for example. In the 17th century, phlogiston was proposed as the hidden substance related during combustion. It remained dominant for more than a century until Lavoisier showed that it needs to be not necessary when oxygen was discovered. In fact, Joseph Priestley, who was also of the discoverers of the oxygen, continues to believe in the phlogiston until his death. And as it's said by Max Planck in this quotation, a new scientific truth does not triumph by convincing its opponents and making them see the light, but rather because its opponents eventually die and the new generation grows up that is familiar with it. I mean, this is summarized by science progresses one funeral at a time. And the last concept before going back to astronomy about, in this case, physiology, was the homunculus. The homunculus was discovered by the father of the microbiology, who is Antonie van Leeuwenhoek. He was a Dutch cloth merchant. He was not a scientist. But he was one of the first in using the first microscope. He was not the inventor, as well as Galileo was not the inventor of the telescope. Looking through these instruments, he liked to see several things and describe them. He only speaks in Dutch, but his work was translated to others to send it to the Royal Society. And I like very much in this book by Alice Roberts, a beautiful book called The Incredible Unlikeness of Being, Evolution and Making of Us. You can read, the semen somehow helps to produce babies. So you get a hold of some. I leave those details to your imagination. And you look at a small drop of that milky fluid using your microscopy. You stare down astounded by the sight that greets your eyes. The whole field is a view of Vicent with movement. You can make out individual tadpole-like cells, thrashing their tails furiously. But these animalcules came from humans. These animalcules, when they came from humans, were called by Nicholas Hatshoker, the author of the page of the scientific page on the right, as homunculus. And the homunculus was a sperm cell with a complete diminutive man there. And this figure inside the sperm try to support the preformist view of the conception, where everything was done by the man. Okay, according with theory, its being exists fully formed, extraordinarily small, in the father's sperm as the homunculus. And the role of the female ovum was limited to providing the nutrients and a place in which the new being would grow. Obviously, those images were there for around 100 years, but new generation of microscopes and microscopists rejected them. In astronomy, we have a beautiful example of the contrary, a postulated entity, as I was saying before, that later was confirmed. For that, first, Uranus was discovered by William Herschel in 1781. Some authors say that it was by chance, but by chance, nothing is possible. I mean, Uranus was discovered by William Herschel because he had the best telescope at the moment, much better than the telescope that were at the observatory, for instance, at the Greenwich Observatory. I mean, he has a very good contact with them, but obviously the telescope is built by him. He was originally a musician, but he enjoyed to astronomy, to optics, and to make telescope with his sister Caroline Herschel. And both of them, in fact, discovered Uranus, but the credit goes for William. He thought at the beginning that it was a comet, and it was also good news, but later they realized that, in fact, it was an object that was a planet moving in a circular orbit beyond Saturn, okay? And this was interesting because for many years, astronomers started to study the new planet. I mean, it was, you know, the new star in the sky was Uranus. That at the beginning, William Herschel wanted to call it George because of the king. Okay, Bode changed his mind, and Uranus, which the astronomy goddess, was a beautiful name. But then Neptune came as a consequence of the Uranus strange movement. In fact, I would like to talk about several women along the talk, and I would like to talk about Mary Somerville, who was the translator, for instance, to English, to the books by Laplace. And Laplace has a very good opinion of her work. And also she wrote several books that were used as textbook in Cambridge for centuries. And this one on the connection of the physical sciences with 5 or 7 editions. In the third editions, in 1836, she suggested that the anomalies in the movement of Uranus could be due to a planet unseen at the moment beyond this orbit. She did not calculate the positions, but her formulation of the problem is often regarded as one of the intellectual influences to, in particular, the Englishmen who did that, John Couch Adams. Here you have John Couch Adams, the more best-known urban leverrier in France, in the Paris Observatory, who did the calculations and found that the anomaly in the not following the Keplerian behavior of the Uranus orbiter was due to the gravitational pull of a planet beyond the orbit of Uranus. And they postulate Neptune. And also, Urban Leverrier calculate precisely where and when to observe. In France, they didn't have the good telescopes for that, but as usually happens, this happened in Germany. They had the money, they had the telescope, and they had the charts. And it was Johann Gale that in 1846 discovered Neptune, and was fantastic because it was a discovery of something that was postulated as a dark entity initially. And suddenly it happens the same with the other side of the solar system. Okay, for instance, in 1859, the same Urban Leverrier recognized an anomaly in the orbit of Mercury. Its perihelion, the point in the orbit closest to the Sun, undergoes a secular advance, okay, what we call it precession, mostly due to a combination of the Sun and Venus, on the gravitational pull of Venus. when we calculate this using Newtonian mechanics, we don't get the observed numbers. And the discrepancy is very tiny. It's 40 arc seconds per century. Okay, this 43 arc seconds per century in the shift of the perihelion was not explained. And a lot of new theories applied. And because the idea of Neptune was wonderful, they create an hypothetical planet. They call it Vulcan, and went Vulcan into the textbooks at the time. I mean, you can see in this textbook that Vulcan lies in an orbit between Mercury and the Sun. And the problem was that many people was looking for Vulcan, and other theories appear. For example, a ring of asteroids, also in the intramercurial orbit, or deviations of the Newton laws, as we today do deviations of the Newton's law to explain dark matter with the month theory. I mean, the history repeats. Okay, this was proposed by Newcomb, who is really a great physicist. All these postulated dragons were slid for those who accepted Einstein's general relativity, because in the framework of the theory of gravitation of Einstein, the shift of the perihelion, the shift of the precession of the perihelion of Mercury is quite well explained. Then we can arrive to our dark matter. Dark matter, in this infographic, the book has a lot of infographics, and also has, as we can see, for instance, Vera Rubin on the right, original drawings. I mean, we try to make the book with these two things at the same time. This infographic highlights the three main observational arguments for dark matter. For instance, first, in 1933, first theory showed that the galaxies in clusters move more far too quickly to be held together by visible matter, okay, suggesting the presence of unseen mass. Second, we have the gravitational lensing, okay? I mean, the light of very far away objects is bent too strongly to be explained only by the luminous matter of the clusters in between, acting as a lens. And finally, in the 1970s, Vera Rubin and Ken Ford demonstrated that spiral galaxies has flat rotation curves, meaning that the stars far from the galactic center move much faster than expected, following a Keplerian law of declining of the speed when you go further from the center of the orbiting object, in this case, the center of the galaxy. Together, these observations establish that dark matter is a central component of modern cosmology, but its nature remains unknown. Here there are many cosmologies, and I cannot avoid saying that for cosmologists, the main belief in dark matter is cosmology itself. I mean, because in particular, and I cannot avoid to say this, it was not in the transparency, but the tiny fluctuations of the temperature in the CMB are so small that with them, and also with the baryonic matter, we couldn't find the structure formation. We need another process of structure formation based on dark matter and cold dark matter, because we know that before recombination, baryonic matter is coupled with radiation. And because this fact, the tiny fluctuations of the radiation are there. But if those are the fluctuations, there is no time to create the structure that we observe in filaments structures. And the reason is because dark matter is not coupled with radiation. The dark matter itself can start the clustering process earlier on, before the recombination. And after recombination, obviously, as we know by baryonic acoustic oscillations and so forth, all this baryonic matter falls down in the potential wells created before by the dark matter itself. And this is a proof that for cosmologists is definitive. Okay. Then we have dark energy. Dark energy has a nice history. In 1917, Einstein proposed cosmological constant. In 1929, Hubble discovered the expansion of the universe, and a few years later, it said that Einstein called it my biggest blunder. And in 1982, astronomers found evidence for it of other kind of quintessence, whatever it has to be. But it's dark energy. That energy was first discovered looking at the supernova state A1, 1A, because they were found by two teams, led by one by Saul Perlmutter and the other by Adam Rees and Brian Smith. Both, the three of them got the Nobel Prize in 2011, I guess, for the discovery of these supernovae that were to find, and the reason to explain the fineness was the only way to explain this fineness was to think that they were farther away than was thinking before. And this is because the expansion of the universe was accelerating. And this acceleration of the universe that we can see here in this plot is what implies the birth of this new lambda CDM model that is the standard one today. Okay, but obviously the dark energy is a very strange component, and there is a lot of proofs working for it. Euclid, many people here are working in this project, and will tell us what happens. I mean, I have a guess. I mean, I have a guess that sooner or later dark matter will be discovered, but I have a guess that also probably dark energy is, and in that sense, dark matter should be Neptune. And dark energy could be Vulcan. I don't know, but this is just to provoke people. Okay, the worst problem is that we have a universe with 95%, according to the best model we have, is made of some form of matter that we do not know anything. We not know anything about. We are ignorant about this part of the matter. But obviously, this is good as well, because there are a lot of projects trying to understand the nature of dark matter and dark energy. Okay. And some of the problems are there. The other day, I was in Valencia with Rafael Rebolo, and we were talking about the Hubble tension in a given moment during the breakfast. And those of us, not many here, that remember the good old days when H naught is, you know, the Hubble constant, which explains the ratio of the universe expands. All of us that we remember the old days when H naught was either 50 or 100, and the ages of the universe was 20 or 10 billion years, have been relieved to see H naught when the Hubble Space Telescope key project led by Wendy Freemet settled the value to 72. We were very happy. The current value, for instance, obtained by Rees using this method that measuring separately distance and velocities and making a division, is now 73 plus minus 1 kilometers per second per megaparsecs. There is a second way of measuring H naught. It's not really a measurement. It can be inferred with high precision for the detailed analysis of the map of the cosmic microwave background. And using data acquired by Planck and WMAP, we can analyze the data, and within a cosmological model, we can determine the state of the universe shortly after the Big Bang. And by means of this cosmological model, we can predict with a lot of precision the value of the constant, of the Hubble constant today. And we get 67.4 plus minus 0.5 kilometers per second per megaparsecs. The observer's techniques has improved and the errors are shrinking. And at the end, we find out that there is what physicists call a 5 sigma tension. I mean, if there's another quote that they have not put here, that it was, I think, by Richard Feynman, say that if you believe something, 1 sigma is enough. If you don't, 15 sigma don't help. Okay. Here it's 5 sigma. It's quite a lot. And this is a tension. And the tension needs a solution. And the solution that could be, we have to, the putative solutions explanation should fall within the framework of the standard model of cosmology. And for instance, it could be something that we have not understood well. We are living and doing the measurements from a particular place of the universe, the Laniakea supercluster, very close to the local void, and this could has an influence on the measurements of the local value of the Hubble constant. But could be something deeper, something deeper. I like very much this text by Licia Verde. Many of you know her. And when she says, we have to recognize that the lambda CDM model, despite its deep connections to fundamental physics and all its successes, is ultimately phenomenological. It established a robust framework in which, however, fundamental issues remain unresolved. Dark energy and dark matter are ad hoc components. These authors believe that it is not unreasonable to think that much like epicycles and luminiferous ether in the past, dark matter and dark energy may be placeholders for something deeper. And in fact, Adam Rees goes further and say, with measurement errors negated, what remains, he is in the other side, not in the CMB, but in the other side. What remains is the real and exciting possibility we have misunderstood the universe. And if this happens, I will win to Enrique Martinez a dinner. And if finally the number is the one that is by the CMB and there is no any other change, and we continue with our standard model, I will pay the dinner. Now it's time to go to more old things in the book. There is a chapter about the dinosaur extinction debate, and this is the second part of the talk that is shorter. And I would like to start also with a beautiful reading during these times from the book. It's also in Spanish, the Peter Brannan book, The Ends of the World, when he says, it seems almost unfair to dwell now on the demise of the dinosaurs rather than celebrate their spectacular reign. Dinosaurs flourished, adapted, diversified, dominated, and mostly impressive, endured for an incomprehensible length of time. Modern humans have been on these planets for far less than 1 million years. Dinosaurs for more than 200 millions. And this creates a lot of images, and filmmakers and Hollywoods are happy with dinosaurs. For instance, we can see these infographics with the Tyrannosaurus Rex and Stegosaurus fighting together. This could not be possible because the former became extinct 88 million years before the latter appeared. Then we need to make some kind of taxonomy, and we did this in the book. We start to be paleontologists in the book for a while. And for instance, this infographic is also in the book, when we can see that each thick blue horizontal line represents a group of species with their ancestor and descendants. They begin and end with the appearance and extinction of the species according to the fossil records. And the black rectangles or the thin lines represent the time interval during which animal shown lived. Biological related groups are connected with thin black lines, like in a family trees. And then we can see, for instance, that the dinosaurs are divided in Ornithischia and Saurischia. And the Saurischia, for instance, are those that the Tyrannosaurus Rex. And from the Saurischia and the Tyrannosaurus Rex, we have at the end the avian dinosaurs. The avian dinosaurs did not disappear 66 million years ago. And in fact, we have some avian dinosaurs today. And this is the descendants, and clearly they are the descendants of that. And you have find a resemblance. And now let's go to see what happened during the time. I mean, about 540 million years ago, we have the Cambrian explosion. The Cambrian explosion gives rise to an enormous diverse and complex life form. It's the beginning of what we call the Phanerozoic Eon. The Phanerozoic Eon means literally visible life. The Earth, instead, was formed 4.5 billion years ago. That those 540 represents only 12% of the Earth's history. Okay. With the Phanerozoic eons, we divided them in periods, and those periods last approximately 45 million each. And some of the names, Triassic, Jurassic, Cretaceous, Paleogene, are names that we remind. And during these 540 million years, 5 mass extinctions have occurred. Okay, here you have the time where these extinctions happened and the different periods on the Phanerozoic eon where this happens. For instance, the Permian Triassic extinction around 252 million years ago was the most severe, wiping out about 95% of all species, okay? The most recent one, around 66 million years ago, was the event in which the non-avian dinosaurs disappeared forever, okay? These have been studied mainly using marine fossils, okay? This graph, it's an old one, showing in the Phanerozoic eon the diversity of marine families. And overall, biodiversity increases always over time, but it was interrupted by several sharp drops that corresponds to the 5 major extinctions. These declines were geologically very rapid, tens of thousands of years rather than millions. Because marine organisms fossilize very well and they are very abundant, the marine fossil record is especially useful for identifying this extinctions pattern and establishing their magnitude. This slide shows, for example, the difference, using the great apes as an example, between family, genus, and species. Family includes several related genera, and the genus contains one or more species. This is important because if an extinction, one species disappears, is a loss, is a loss, but it's not as terrible as when the extinction of a whole genus or family, which is much a problem for the evolutionary diversity. In fact, for example, in our case, which are hominids, we are the humans as a genus, and this genus has a single species today, okay, which is the Homo sapiens. But it has been other species that we know the names, for instance, Homo neanderthalis, or Homo erectus, or Homo habilis, that they has disappeared already. And there are other genera as well. For instance, the Australopithecus will be different of humans in the genus scale, okay? The extinction of a family is catastrophic, certainly. And here you have, this is a graph from the book, a history of the different extinctions, okay? And what we can see, for instance, is when it happened, the percentage of family, genera, and species that disappear in each of the extinctions, and the most likely causes. And as we can see, there is a common denominator of all these extinctions. We could say that it's a major environmental disruption. What is the cause? Could be always climate change and sea level change, but this could be created by volcanism or by asteroid impacts. But as you will see later, asteroid impacts only we can relate it with one of these extinctions. So what did happen 66 million years ago? Before to go in that, I will also like to talk about 2 women whose contributions were crucial to the story of Earth and life sciences, yet whose work was long under-recognized. On the left, we have Mary Anning, who played a fundamental role in early paleontology through her fossil discoveries. He was a fossil collector. He discovered, for instance, the first complete plesiosaurs, and she never got the recognition she deserved. On the right, we have Mary Sharp, who transformed geology by producing the first detailed maps of the Atlantic Ocean floor, helping, for example, to reveal the Mid-Atlantic Ridge and Rift Valley. Different centuries and in different disciplines, both women changed the way we understand the history of Earth, even through neither received full credit at their time. The disappearance from the fossil record 66 million years ago was recognized already in the 19th century, but did not become a serious part of the scientific debate until the 1960s. But For instance, in 1978, nearly 50 years ago, Dewey McLean published his most important paper in Science, suggesting the elevated levels of carbon dioxide in the atmosphere caused the global greenhouse. And the subtitle of the paper, I think that I have here, is Lessons from the Past. Lessons from the past, already in 1978, okay? In the 1980s, physicist Luis Alvarez, who was the father, and his son Walter, who was a geologist, suggested that a large meteorite impact was responsible for this extinction. The subsequent discovery of the Chicxulub crater seemed to settle this matter once and for all. And disliked many people, and this is obviously still the standard reason if you ask to a child of 10 years old what was the cause of the extinction of the dinosaurs, he will say a meteorite or a bolide of a comet or whatever. But the history starts very beautifully as well. This is a beautiful history, also a collaboration between father and son, and physicists who had a Nobel Prize on nuclear physics. Also, he has quite a different history. He was one of the people who worked in the Manhattan Project under the orders of Oppenheimer. But he was also the guy who was in the observer plane that was it was called the Great Artist, the plane that was behind the plane that just left the atomic bomb on Hiroshima. Okay, this is his history. We know very well about Luis Alvarez. The young Walter Alvarez, a budding paleontologist, visited Gubbio in Italy in 1977 to study the geological clay boundary between the Cretaceous and the Paleogene periods. By the way, the Paleogene, for those of us that was called before the Tertiary. Now it's called Paleogene. Okay. The boundary marks a time, exactly 66 million years ago, when there was known to have this massive extinction of animal life. On getting home with the samples, Walter discussed this work with his father, who has been awarded the Nobel Prize in nuclear physics, and Louis suggested that they do a test on the clay, okay? And here we have both of them with the clay, and the clay was found in many places in the world, okay? Louis enrolled several nuclear physicists, Franz Saro and Helen Mitchell, to do the nuclear analysis of 28 atomic elements, and 27 of them proved to be quite normal. The 28th element, iridium, was measured having 5.5 parts per billion, 55 times more than the normal. The element is very rare in the Earth, only 0.1 parts per million. So the iridium was not made here. That's the conclusion. The simplest conclusion was that it was brought into the Earth by a meteorite. The next phase of the work was to check this, and this is how science works. And this is beautiful, really beautiful. The iridium was measured, and it was enough to postulate the impact. And even at that time, we know the size and the characteristics of the impact, okay, without being able to find what the Americans like to call the smoking gun, the crater, okay? The iridium also was measured in numerous places. For instance, we can find the same iridium here in Spain, in Zumaya, in the Flix. Okay, you can find this clay of layer of clay, and also you have this amount of iridium there. But the problem was that this was not a theory that paleontologists like. In fact, at that time, also that theory was criticized. For instance, we can read in the New York Times that astronomers who leave the astrologers to know what happens in the past, things like that, because they really were against this idea. But a theory was born, and because this iridium in the Gubbio clay value was enough to create this theory. But at that time, we have to recognize that the favorite idea was that the extinction was due to volcanism, and we will go back to this idea later. And invoking this astronomical explanation was perhaps the last thought of many people. The weak point at that moment was that there was not a crater left by the meteor. And finally, the crater was Beetle. And in 1991, 11 years later, of the idea of the iridium coming from a meteorite, the crater was discovered. In fact, Glenn Plimfield had discovered the crater 11 years earlier. But in this field of geology, when the oil companies are in, there is absolutely secret. Okay, the crater was known by the geologists working for a given oil company. Okay, and at a given moment they explain it. Then what we as scientists try to do is to create correlations, and then we can. This idea is nice. Okay, it's very like very much to Hollywood filmmakers, for example. And but what this is always the reason of the extinctions. For example, we can make a catalog of the largest craters, and the top 10 are here. And only one of these craters can be related with extinction, okay? And for the other major extinctions, the temporal correspondence is very weak or absent, okay? This is what, for instance, is explained by Bond and Grasby. The absence of convincing temporal links between impacts and extinctions, other than the end of the Cretaceous, suggests that impacts are not the primary drivers of the extinction. Then enter Gerta Keller. Keller was a participant in the earliest NOMAS conference that had been organized to discuss the iridium problem. It was the idea of promoting the asteroid strike. And during that period and beyond, Keller had suffered considerable verbal abuse and derision from the asteroid strike supporters. For instance, Luis Alvarez always said that geologists were not scientists, they were stamp collectors. And he published this in New York Times and things like that. I mean, this kind of expressions, but in particular against Gerta Keller, it was quite nasty. And in fact, she has published a book, The Last Extinction, a few months ago. The book will be translated into Spanish next month. And explain this history. It's more not a scientific book, but a book of memories where she explains 40 years of her career. But to understand the point, the divide did not stay inside science. It became public. And for example, in this mature outlet called The Atlantic, very serious one, and in several BBC documentaries, this was discussed. And this tells us something important. This was not just seen as a technical disagreement between the scientific community. It was a controversy, but it creates also personal conflicts. The impact also, we can just read here, a Princeton geologist has endured decades of ridicule for arguing that the fifth extinction was caused not by asteroid, but by a series of colossal volcanic eruptions. Okay, and the feud is about explaining the extinctions. And what Gerta Keller claims is that at the same time, 16 million years ago, it was a massive period of volcanic eruptions that has created what are called the Deccan Traps. The Deccan Traps is a region in India where the magma expelled from the Earth interior during tens of thousands, or probably hundreds of thousands of years, covers an area roughly the size of France, with lava flows more than 3 kilometers thick in some places. Here we have an image where we can see this hardened lava in the Deccan Traps in the Western Indians, which is the remnant of an intense volcanic activity. And then what we can see is that this is the picture, okay? The picture of the Deccan Traps. And here we can see the place where this area covers, and also we can see that goes beyond the ocean till the Seychelles Islands, okay, on the Arabian Sea, okay. We can understand that the hot region below the surface is called mantle, and the mantle is very hot. It has a temperature of 1,400 degrees Celsius, and in some points higher. And we can think this as a blowtorch, and as the tectonic plate moves around, because the continental drift, we talk also about the continental drift by Alfred Wegener, and the reason it was very difficult for him, for many people, to put this idea on the scientific community. I mean, this is a couple entitled Non-Invented Here. I mean, non-invented here means that when a scientist from a different field comes with a good idea, typically people reject it. And there is a whole book by Naomi Orested explaining the rejection in America of the continental drift hypothesis by Alfred Wegener. Okay, but just because the continental drift, this blowtorch can cause volcanoes along its path, creating a set of islands as Hawaii or as Canarias, of course. The heated areas can be vast, and they are referred as large igneous provinces, LIP for short. LIP is large igneous provinces. Here we can see a map of the main LIP in the wall, and they are related in many cases with the extinction, with the massive extinctions. For instance, in Peter Brandenburg, we can see that the three biggest mass extinctions in the past 300 million years are all associated with giant floods of lava on a continental scales. And you have the Siberian traps for the Permian-Triassic extinction, the Central Atlantic Marine Province LIP for the Triassic-Jurassic, and the Deccan traps in India for the Cretaceous-Paleogene. Okay. Here we can see, for instance, in this transparency, time flows from top to bottom. The 5 great extinctions are shown as before. And we could talk about the different toxic elements or elements that provoke acidification of the oceans, acid sulfuric, but in particular in this diagram, I have focused on the mercury. Okay, the mercury is poison produced by the volcanism. It's a byproduct of the volcanism. So the detection of mercury are marked here by blue stars, and the corresponding LAP is noted. Almost all the starred events are assigned to LAP, okay? And in fact, this is something that connects clearly in terms of measurements the large igneous provinces with the massive extinctions. I am finishing. Dinosaur biodiversity declined. Well, this would be the idea, the infographics of the other idea of the Goethe-Keller proposal. Dinosaurs biodiversity declined well before the asteroid impact. And this is something that is well known, although it's also controversial. This is also controversial. That means that there were ecological and environmental pressures that makes the decline of living dinosaurs was decreasing. The biodiversity was decreasing during the last hundreds of years before the end of the Cretaceous. Okay, and then the KPG, or the Cretaceous-Paleogene boundary, which is determined by the species death, happened 66 million years ago, and only one species of foram, the foraminifera, as we have seen here. Sorry, I did not comment. Foraminifera are these single cells, but with shells, with different membranes, and this is the fossil that is mainly studied by many paleontologists. It's a marine fossil, and the number counts of the fossils explains very well the magnitude of the extinctions. And certainly, using this foraminifera, we can just see that only at this moment one species of foram survived and still exists today. The others disappear. And one of the conclusions of the studies of Goethe-Keller is that the meteorite appeared 200,000 years before the end of the Cretaceous. That means that the extinction happens at this moment, the Cretaceous-Paleogene boundary, but the impact of the meteorite, it happened 200,000 years before. And as the many people who works in this impacto theory, the idea of the end of the life caused by an asteroid is the idea of a bad weekend. I mean, it happens geologically in a very short period of time, a bad weekend. I mean, not in a long, it's catastrophe in front of gradualism, if we want to go to the old idea of ecology, okay? And but this, it's not clearly seen in the fossil records. I mean, it seems clear that the 200,000 years is the period that predates the impact to the end of the Cretaceous, which marks the extinction moment. This conclusion first came from finding the tiny glass spherules associated with the impact at levels lower than the extinction layer, okay? For instance, the others say that it was the consequence of a tsunami that moved everything, okay? But, you know, the debate is there, and we like it very much to include this in the book because it was a contemporary debate. We are not experts on that. I mean, if Licandro was here, he will probably smash me with much more knowledge of asteroids. But I would like just to conclude with an idea, and I like very much to study asteroids, and I think it is very important to study the near asteroids because they could be dangerous. I will finish with this idea. But this fact that the 200,000 years predates the boundary, the KPG boundary, was later confirmed by investigating at other sites around the crater and in other parts of the world. That means that in that sense, it seems, looking at the fossil record, that the meteorite had little impact in the fossil record. It not was the cause of the extinction, except probably locally. I mean, it was not necessary, not a sufficient condition for the extinction. And it will contribute, obviously, to the global climate and the habitat change. And probably there are people saying that also could drive the more eruptions in the Deccan Traps, having in the opposite side of the Earth. But you know, the Earth is a very connected system. Okay, for instance, in this diagram, the group by Gerta Klerer is providing the first evidence in these pictures of that the impact predates the extinction by some 200,000 years. And I am finishing with a graph that tried to summarize these things by the book by Gerta Keller. This data shows, for instance, that the mature mercury peaks between 66.57 and 66 million years ago are marked here. Here you have where the meteorite strike, and the red horizontal line there is the end of Cretaceous line. And we can see that before that, we have intense volcanic eruptions indicating hyperthermal warming and culminating in a near continuous eruptive phase across the Cretaceous Paleogene boundary. Just to take away this idea that I like to read it here, NASA has already responded to the fears of meteor strike by launching the DART mission, a beautiful mission. I love the people working. I know, for instance, it was one of my former collaborators, Adriano Campo in Alicante, and all the people who worked on DART, to redirect an asteroid. But a speeding rock from the outer solar system is not our most fundamental threat. Slowness is. The Earth is hitting by human designs, just not fast enough to mobilize action. That is why I prefer Keller to Albert. All other issues aside, she clarifies that what is now happening to the planet has happened before, and the same ending has repeated itself 5 times. Thank you.
Okay, thank you very much. Now we have time for questions. Are there any questions?
Thanks a lot for this inspiring talk. Now we were about the dinosaurs, and the question is there now direct evidence that the dinosaurs survived 200,000 years after the meteorite impact? Can anything be stated about that?
I mean, the evidence looking at the fossil record, it's very difficult to answer that question, because what people can study are small, in order to be fine to do this, we have to look at some kind of tracer, in that case the foraminifera, that gives you a continuous impression. But whenever we want to, for instance, to find the date of a given fossil, the dates are very long. I mean, we cannot say that we have found, of course, we have found, let me put it in this way. There are fossils of dinosaurs before the impact of the meteorite, if the impact of the meteorite happened when Gerta Keller puts it. What the other team makes is to put it farther away, closer to the end Cretaceous. Okay, the problem here is the dating of the impact. Okay. What I mean is that we should not take for granted that this 200,000, which is the numbers that Gerta Keller and her team provides, are just for sure, because the other team put it further away, closer to the border. Here, the beautiful thing is that the solution probably does not come from paleontology. It will come from physics again, because the dating is radiometer. And then using argon-argon or uranium-lead transitions, you can just measure better the date. The date exactly when this happens. But this is still a matter of debate. I remember that when we were writing this, there were a couple of papers in Nature, one by the group by Alvarez and one by the group by Gerta Keller, using different traces. One uses the uranium lead, the other used the argon-argon transition, which came also from the potassium one, and they reached to different conclusions. And this is a matter of debate, and this is beautiful because it's a scientific debate, and I'm very happy with that. Because I don't want to buy, this is what I prefer, but I don't want to buy it scientifically. I am not an expert, and I want to read more, and I think that it is not conclusive. But I think that it's a quite interesting field, because makes a lot of multidisciplinary science. For example, for people who likes to make models of what happens with a meteorite strike on the Earth and on the atmosphere, and the global warming and the greenhouse effect. And this is beautiful. I have been talking that the first models were providing this idea of a bad weekend very shortly. Bad weekend could be 1,000 years, if you want, in geological times. But it could be longer. Or, for instance, it could be a relation that still is not clear between the volcanoes and the strike. What is clear is both happened more or less simultaneously. And we have to deal with that and to find the reasons. And obviously, if we had not the decant traps, the meteorite alone should be probably the explanation. But having both things, we have to put the emphasis to understand better the physical processes, and being a community that are more or less outside. And for instance, I have to say that Virginia Trimble knew a lot of paleontology. I enjoy very much my discussions with her. Bernard Jones as well, who was the author of this part of the book, and his wife, Janet Jones, has been working with the people who study the sea floor for many years, and they discovered several things related with the paleontology or oceanography that helps to understand the problem.
Thank you.
Hi. Yeah, so I have a question because of what I really like the idea of you were showing the evolution of the science and how we go back in time and how we cycle with the same type of process. But there was also this idea of Michel Foucault that you have this epistemology and the science is bound to the society as well. And so you have an evolution of the societies with time and what's happening in the ancient Greek time is not the same that what happened during Herschel time or what is happening now. And my question is, how do you see, or what are the mistakes that people made in the past with the link between science and societies that we should not try to reproduce right now? Did you find any
No,
pattern like
yeah,
this?
I think my conclusion is very simple on that. I think that we need to have a broad view of science, and I have met many people who believe in something and they feel very uncomfortable to move on. I remember once, but it's a person that I have a lot of appreciation to him, but just to give you an idea, it was in Manchester in the IIU in 2000. It was a session that probably Rafa was there. I have been given a talk on large scale structure. It was Jim Peebles, it was Wendy Freeman, and it was a discussion table there. And it was the time, 2000, 2 years later, of the supernovae. And the first lambda CDM models were there. But it was a 3 sigma at that moment. And I remember that Peebles from the floor said, well, but within 3 sigma, I could stay believing in an Einstein de Sitter universe. And once from the bottom say, but you will be alone. I mean, the idea that things were changing, but you don't want to change too early. I mean, it's more or less the Alexander Pope quotation at the beginning. But going to your questions, things repeat. And for instance, with the ether, okay, with the Michelson-Morley experiment, nobody followed it until Einstein special relativity, but even later. In 1932, there is a paper on Review of Modern Physics and a counterpart in Nature explaining that the experiment gives positive results with a velocity of 208 kilometers per second. Okay, we are talking about 1932 and 2 mature journals. You probably remind the people who did that. Okay, it was I don't think that I have put it in the talk, but it was something that things needs time to change. Okay, and believing in ether was something that probably many people. Well, it was Dayton Miller, the ether drift experiment in the determination of the absolute motion of the Earth, 1933. Okay, it's nearly 50 years after the Michelson-Morley experiment. Okay. I mean, I think that things have, but for instance, in nuclear, in high energy physics, the neutrino was an entity that was postulated 3 or 4 years before the discovery. The Higgs boson, 50 years, but at the end, this discovery. We are about 100 years of the dark matter idea by Fritz Zwicky and probably but other people earlier. For instance, Captain was also talking about dark matter. This is planned in the book. And sooner or later, we have to find something. Our times as astronomers probably are longer than the high energy physicists, and I don't care about that. But things repeat, and we have not to, we cannot say our belief. We cannot say our belief in dark matter has a more sound scientific base than the belief on the ether as the material to propagate light at the end of the 19th century. Because the science at the given moment is the science that they have or we have. And we have to be not so proud with our time. We have to be proud because we are creating a beautiful science, but we could be wrong. And we have to be open to this idea.
Okay, we have 2 questions in Zoom. I remember there were a few works linking the position of the solar system in the galaxy with extinctions in ancient times. Do you know if this is currently considered a feasible explanation for some of the extinctions you mentioned?
Yeah, that's a beautiful question. This is Lisa Randall idea. Lisa Randall has a particular idea of an exotic kind of dark matter, okay? And Lisa Randall is a wonderful physicist and a wonderful disseminator of science. And she has very nice books. For instance, one called Knocking to the Heaven's Door, something like that. But there is a book by Lisa Randall called Dark Matter and the Extinction of the Dinosaurs. That's it. That's it. And I think it's also translated into Spanish. And the idea is very simple. For her, the first caution, the asteroid impact should be a comet impact. Okay, for us, this is important. It cannot be an asteroid, it has to be a comet. Why? Because when you start to see not only the massive extinction, but the lesser ones, you see a periodic process, okay? Which it's not 66 million years, but half of that, okay? Half of that, counting the lesser and the mass and the greater extinctions. And you have this behavior. And in her model of dark matter, this dark matter has the property, I don't remember why, that lies within a thin layer parallel to the galactic plane. In the same place of the galactic plane, we will have an amount of dark matter, of this particular Lisa Randall kind of dark matter that I don't remember what's name. Obviously, she does not call it Lisa Randall dark matter. It's a kind of exotic dark matter. But what happened there is because the solar system is going around the center of the galaxy with a speed of 220 kilometers per second. It's doing this wobbling. That means that the solar plane, the galactic plane, crosses this thin layer of our solar system, crosses this layer of dark matter in the galactic plane. It's 34 million years. And what Lisa claims is that this dark matter is acting on the Oort cloud, moving comets toward the Earth, okay? And this is likely, and she did very well calculations. And if this dark matter exists, this could be an explanation. But in this case, the explanation of the extinctions, massive or lesser, will be related with collisions by comets. Beautiful, beautiful. Probably nonsense, but beautiful.
Okay. We have one last one here, which is that I've already read that we are now witnessing a new mass extinction driven by human activities in the last centuries. I was wondering if you know any numbers as percentage of species erased from Earth related to this kind of claim.
Yes, I don't have here the numbers, but certainly there are people talking about the sixth extinction driven by the human activity. However, in fact, I conclude with more or less this idea, not in my words, but in other words, commenting the work by Gerthe Keller. However, I think that here we have to be cautious. I mean, it's true that global warming is related directly and with the human activity. But as scientists, we have to understand that the changes that has produced massive extinctions in the past are also related with other cycles of, for instance, many of you, for instance, know the Milosevic cycles, which are due to the variations of the, for instance, of the inclination of the ecliptic with secular times. And the Milosevic cycles are also related. And in fact, I think that I have some of, this was the Milankovitch, sorry, I pronounced, the oscillations are mostly due to the planetary Milankovitch cycles affecting the tilt of the Earth axis, okay? These are oscillations that affect the global temperature. In fact, fortunately, we are now going up. instead of going back. But this is something that has to be related also with the extinctions, and this comes in our field from astronomy. The case of Milankovitch is a case of non-invented here again. It's a scientist that probably has been hiding Milutin Milankovitch from many people. Also, the levels of the sea has changed too much. Okay. Here we have, for example, in this phanerozoic eon, the sea level has changed a lot. Okay, I didn't want to conclude that the human activity is related with the sixth extinction. I believe that this is true. But in order to understand the whole global things, we have to look very well the history. And by natural reasons, sea level changes, temperature changes, and we have also to understand all these reasons, how they act and are related with our activity. Okay, and of course, I agree with the question. I think that it's true. We have to make sure that we can avoid our guilty in creating this extinction, but also we have to know that this lesson from the past is relating for what we are going to do, but also what we are going to study in relation with the other extinctions. And these things of the change of the sea level, of the temperature change, are absolutely important. When they are cycles, we have to be prepared for that.
Okay, so let's thank the speaker again. And now we're free to go, except the students that want the colloquium counted for the PhD program. You can please come here.
Okay. Well.
Yes.
Muy bien.
No, yo digo la velocidad y el nivel de inicio coinciden. Puede cancelar. Exactamente. Si coinciden por debajo de ella y sus de nitrogen y por encima no los hay. Y los fragmentos por debajo de la zona de nitrogen que se ofrece. Hay muchas especies de foraminíferos con esas más entonces, yo puedo entender que los dinosaurios ya estaban en todo. De acuerdo. Pero si eso es así, eso significa que el meteorito le dio la vida.
Puede ser, porque tiene
le dio la funcionilla.
Es que al final es la más razón.
O sea, porque si no hay, si tenemos, o sea, si hubiera habido fósiles de dinosaurios o especies en los estratos o de encima de la capa de ilicio, yo te hubiera dicho de que, vale, de que la extinción seguía en curso y de pronto se produce. Pero si no hay, si por encima de la franja de ilicio, que coincide con la franja de sí, pero es la que ha llegado a la pero no por debajo. Viene el dinosaurio por encima de la franja de iridio. Pero creo que hay más calidad contra porque estaba
Yo salgo a las 9 de clase. Quedad vosotros y yo tengo
Sí, bueno, si lo va a hacer. Este es el de Valencia. Ya, ya.